Welcome to Laser Thermal. Today we're going to go through a tutorial on how to make a TOPS measurement. So you can see we have a variety of different samples already prepped, having different shapes, dimensions, thicknesses, from foams to metals to acrylics. And Nick's going to show us first how to apply our transducer film to the sample.
Hello. So here is the transducer film, and I'm going to be applying it to an example of a bulk material that we would normally test here at Laser Thermal. So the first thing I'm going to do is I'm going to take this film, and there's these little corners that have been engraved into this film itself. I'm going to peel up this corner. I'm going to start to pull up the edge of the film. I'm going to start to lay it on top of my bulk sample and pull the film over. And it's okay if you see a few wrinkles right now, that's not a problem. So that's why I have it overhanging the edge a little bit. It makes it a little bit easier so I can now lift the edges, pull it taut, kind of like tensioning a drum head. Pulling it taut, pulling it around. And it does not have to be 100% perfect because you have to remember our spot size is right around 1 millimeter. So as long as I have a good 3 millimeter spot where I can get my laser in there, everything will work out fine. And this is an example of a prepped sample. Okay, so now that we have applied the transducer film to our bulk sample, I'm going to pass off the sample to Jeff, and he is going to proceed to take the measurement in our TOPS machine and determine the thermal conductivity.
Thanks, Nick. So the sample has been prepped, and at this point, we'll open the door and place our sample into the machine, and you'll see that the stage has an engraved target to make it easy for you to apply the sample where it needs to be centered on our infrared image. So I'll go ahead and close the door. And we can see now that we're starting to see some contrast, indicating that the sample is visible. What we need to do from here is adjust the stage height in order to focus the sample. And we have a rule of thumb as to where to place the stage position based on the height of the sample. But I know from experience that for a sample this height, will be around 30 millimeters. So I'll just go ahead and move the stage roughly where it needs to be. And we can start to see some contrast in the image, indicating that we can see our sample surface. At this point, I'll go ahead and turn the laser on. For a conductive sample like this, we won't see anything at low powers, but if I max out the power of our laser at 110 milliwatts, we can start to see the heated region of our sample. So I'm not quite in focus. We'll know we're in focus when the heated region is perfectly centered in our infrared image. So I'll go ahead and at this point run our alignment procedure. So I can go up to alignment and press autofocus or hit Control F on the keyboard as a shortcut. At this point, the TOPS tool will take over and adjust the stage height in order to center the position of the laser on the infrared image. So you can see the procedure is finished, and we can now zoom into our image and see how well the procedure worked. Seems like we got pretty close, but we might want to do some fine tuning. So we'll go ahead and adjust this just by a few pixels just to get perfectly centered. And you'll see from the crosshairs and comparison to the position of our heated region that we're pretty close. But we can go ahead and check that by going up to alignment, check center, just to confirm that we are indeed centered on our image. In the diagnostics tab, we'll see an output of the center coordinate, and we're looking for somewhere around 320 by 240 as our center of our image. So we did a good job here. We know we're centered. At this point, I can go ahead and turn off the laser and proceed to my measurement. Before I do so, I'm going to go ahead and name my sample. So I'll just call this test sample. And I'll adjust the measurement parameters. So we have here 4 different parameters to adjust: the average time, wait time, the number of points, and our max power. So to adjust the max power, we first want to see what the temperature rise we're getting at our laser power is. So to do that, I'm going to go ahead and first go to IR camera tab and subtract image. And what this does is it subtracts the current frame from all future frames, so we can get rid of noise at the sample surface and just see temperature differences when we turn our laser on. So I'm going to go ahead and turn our laser on at max power. We typically recommend a measurement to be around 5 degrees Celsius in temperature rise. But in this case, we're already maxing our power out, and this is a conductive sample. So we're only getting around 3.3 Celsius. So it's good enough to make a measurement. So we'll just go ahead and use the max power we have currently as our measurement power. So I'm going to go ahead and turn this laser off, unsubtract my image, and then I'll go over here and set my max power to 110 milliwatts. As far as the averaging time goes, this is the amount of time we take to make a single point measurement. So when we turn our laser on, we wait a certain amount of time, and then we average for a certain amount of time. So for a conductive sample, we only need about 5 seconds of averaging time and 5 seconds of wait time. For an insulating samples, you may want to increase the wait time further so you can ensure your sample reaches steady state. And this is something that you'll get a feel for as you measure more samples. But typically around 30 seconds is good enough for most samples, even the most insulating ones. Okay, so with that, I have my measurement parameters defined. I'm using it 5 seconds averaging time, 5 seconds wait time, a max power of 110 milliwatts. And I'm going to use a typical number of points of being 5. But if you wanted to push your measurement to be faster, you could use 2 points and likely get a similar value. So at this point, I'll go ahead and measure my sample. So I'll press the measurement button. We'll see a progress bar pop up showing the measurement in progress. And if I move that to the left, I can see the current real-time data of the temperature rise. And we see that it starts with no laser power applied, and then we turn on the first laser power and we wait 5 seconds, average 5 seconds, and then we apply that same procedure at increasing powers. And with each new point obtained, the software will show the current value of thermal conductivity by what it's doing is fitting a model to the current data. And as you get more points of your data, that number will be refined. So at each point, we refine the data and get a new value. So at this point, we're 80% complete. We have one more point to go, and we've just finished our measurement. So once the measurement's complete, the value of the thermal conductivity will be printed along with the sample name in the Diagnostics tab, and the results will be printed to the table in the bottom right. And so all preceding tests will do the same thing where the software will print the sample name as well as the thermal conductivity in the bottom right here. And if I highlight any file in this table, it will show me the data to that file in the plot. So that's it. We've made our first TOPS measurement.
And to summarize, we started with taking our bulk sample and applying the transducer film. Then we took our sample and placed it into the TOPS machine so we could determine the sample's thermal conductivity.
We adjusted the stage height in order to focus the sample in the IR camera, and then we adjusted the measurement parameters to make a thermal conductivity measurement.
Please reach out to Laser Thermal if you have any questions or inquiries about the TOPS system and technology.
We're confident that this TOPS measurement will help you innovate better and faster, paving the way to your success. Thank you.
Thank you.